So let's take a look at this problem. You hold a ball in your hand at a fixed height, release it, and release it. So it's released from rest. Its initial acceleration, the moment after you let it go, is what? Well, we're going to take our ball. It's going to start at some height, initial height. Call it x naught. I'll say the ground is at 0. And we're going to let it go. And we want to know what is the acceleration. Well, this object is released from rest, so its initial velocity is 0. Its acceleration, on the other hand, even though it's released from rest, is not 0. It's actually at a value of g. It's got the value of gravity. Assume we do this on the Earth, it would be 9.8 meters per second. And almost as important, or sometimes even more important, as in this question, it's in a downward direction. It's in a downward direction. Gravity pulls the ball towards the Earth. So what's going to happen is this object, this little ball, is going to start with 0 velocity. Because it has an acceleration, acceleration is going to start to change the velocity. So as time progresses, its initial velocity is 0, but it's going to acquire a downward gravity. And I'm going to assume in this case that up is my positive y direction. So it's going to acquire a downward gravity component. As the time increases, the velocity is going to get more and more negative, which means that the velocity will become larger and larger as this goes down. Gravity is always acting on it. The Earth is always pulling on this ball. After we release it, our fingers are no longer holding it up in place, but the ball acquires gravity, a downward gravity acceleration. The correct answer for this one is C.